Hey class, how are you? Thank you for staying with us. I know it's been a while now since we've been together in person. I know it's probably getting kind of old, so hopefully you can just hang with us here. We have a few more weeks left. Today I'm going to talk about a new conic section. We've talked about circles. Today I'm going to introduce ellipses, and we'll do a few days on this. And we'll do a short assessment. But before I do that, I don't know if there's things that you can or can't get during this pandemic um, for you personally that have bothered you. But the one thing that's really bothered me is this. I'll show you guys. So I don't know if you can take a look at that. That's the Doritos spicy sweet chili, and honestly, I've had the hardest time finding these, and I found this bag. A friend of mine found this bag for me and dropped it off last night, but I can't find it anywhere. Can't find it in Stores Cub, Kowalski's, Menards. Menards used to be my go-to for this, but it's kind of weird how things like toilet paper and food and yeast and flour and I guess Doritos purple sweet spicy chili is just you can't find them. It's unexplainable. I don't understand it. It's not mathematical in reason, but anyways, yeah, kind of excited to get into that bag today. I haven't had those for weeks, and I've been craving them. So, without further ado, you guys, we got a little terminology today. We're going to start talking about ellipses. So, there's a formal definition for ellipse. I'll let you take a peek at it here. It goes on to talk about what an ellipse is and how an ellipse is not centered around a center per se, and that all the points are not equidistant from the center. These points are equidistant from these two things called the foci. So unlike a circle with a singular focus, this thing has two of them. We'll talk about more about the foci later. The uneducated mathematical version of an ellipse is like an egg or an oval. So there are some other pieces of terminology that I do want to talk about. Let me move this out of the way here. So we talked about it not having a single radius. Like a center, I guess, it does have, or like a circle, it does have a center. So we got that going for us. Because the points vary in distance from the center, that's what creates the egg shape. We have four particular points, each come in pairs that are super important. One of those pairs goes along something called the major axis. That's basically the longer of the two axes. That's why it creates an egg. And the other one comes along the minor axis. Now, the pair of points on the major axis, the endpoints, are called the vertices. The one on the minor axis, the smaller one, are called the covertices. We're also going to focus on center today. So today, our single focus is equation of an ellipse, find the center, find these covertices, and find the find the vertices and the covertices. Before we can do that, here is the equation for standard form of an ellipse. It's similar to a circle. It's got x squared and y squared, and it's a plus sum on this side. It equals a number. The difference is it always equals the number 1 in standard form for an ellipse. And these are fractions, okay? So we'll talk a little bit about those in a little bit. These two numbers are super important. A is always larger than B. A signifies the distance away from the center or length for a vertex. So if we can take the square root of whatever this number is, that tells us how far away the vertex is from the center. And same thing with letter B. Letter B is the distance away from the center to the covertex. All right? So if something's in standard form, it's going to create an ellipse that looks like this. This is an egg ellipse. The one piece of note here is if A and B are switched, if A is over on this side here, and again, whatever one's larger. If this number underneath here is larger than this number, then this is going to be an egg or an oval that's more vertical instead of horizontal. So it still always has one axis that's larger than the other. Both of them go right through the center. Today we're just going to look at ellipses that go through the origin that are centered at 0, 0. Okay, so if you see something that's x squared plus y squared with no parentheses and no subtraction up top here, then it does go through the center. Two types of problems to look at today. This first one here is going to look like this. It gives you an equation. It says find the center, find the vertices, find the covertices. All right, so the first thing that I do with a problem like this is I might sketch this problem down on paper. All right, so to find the center, basically I'm going to look at these up here. And if I don't see plus or minus with parentheses up here, like I did with circles, then my center is at the origin, 0, 0. And like I said, today, all of our ellipses will be centered at the origin. All right, so that's number one. Number two, then, to find the vertices, I might do a sketch of this. So I'm going to sketch this out. I'm going to put my center right here at the origin. And then what I do is I look up here, and I take this number. This is the larger of the two numbers, so that's A. And it's actually a squared. So if I take the square root of that, that's going to give me what a is. A is 5. Well, what that means is this, it means from the center in this direction, the x direction, 5 units in both directions, that's going to be my major axis, or the large axis. All right. This other number right here tells me from the center in this direction underneath y, square root of that is going to be 3 units in the y direction. That's going to be my minor axis. And so if I was to sketch this little oval here, oval looks like this. The sketch might help me with these things. Number 2 says find the vertices. So the vertices are the larger axis. They are the coordinates of these points. So by looking at my sketch here, I can tell that this is 1, 2, 3, 4, 5, 0. And the other vertice is -5, 0. The third thing then is find your covertices. Our covertices are 0, 3, this one up here, and this one up here. The covertices are always the smaller axes. And there we go. Let's try another one. Let's look at an ellipse, a fascinating little conic section, but let's look at an ellipse that's the other direction. So let's take a peek here. Here would be an ellipse. Again, we look up here to see where it's centered. If you don't see any plus or minus, like in our transformation rules, our center is at the origin. So when I'm sketching this graph right here, I'm going to put my center right here. And then what I'm going to do next is I'm going to look at these numbers. I'm going to start with the larger the number. See how the larger the number is underneath here? 36 is larger than 16. So I'm going to take the square root of that, and that's going to be 6. 6 is letter A. And letter A is the distance from the center to the vertex. We don't always just go horizontal. We go whatever direction the variable tells us to. In this case, the variable is y, so we're going to go in the y direction. Which makes our vertex 0, 6, 0, -6. Now let's do our covertex. Our covertex is this other number here, this one right here. Square root of that is 4. Again, you can think about it as plus or minus. We're talking about a length here. So that's just 4 units away from the center. And it's horizontally because of this x variable right here. Boom, boom. There's my sketch. The sketch just helps me logic or just helps me find these vertices. 4, 0. This is for my covertex now. -4, 0. Okay? So bottom line is we're actually finding these 3 things. Center, vertices, covertices. And sometimes our ellipse is the other direction. So do a little bit of practice on ellipses. Good luck, everybody. Until next time, friends, stay clean, wash your hands, disinfect your phones, and most importantly, be kind.